We are in part 4a where we now have parabolas, and we are trying to graph these parabolas right here. Now, parabola is any function where we have y equal to a function where we have an x squared term. So it could be something with a number in front of x squared. It could have an x term and a number term along with that, or not. Anything where the highest powered term is to the second power in x squared. So the first thing that we're going to do, no matter how you want to figure out how to graph these parabolas, is to figure out where the vertex is. And when you think of a parabola, it's a U-shaped graph, either going up or going down, and the vertex is either the top of the graph if it's going down or the bottom of the graph if it's going up. Because in the other directions it goes to infinity, but at that single point, if we can find that, then it's going to be symmetrical on either side. You could fold these things in half and it would fold over itself. So to find that point, the key to finding that point is to use a simple formula that says x equals negative b over 2a. And what that's going to do is that's going to tell you the x coordinate of the vertex. To get the y, you have to plug it back into your original function. So let's go ahead and try that. In this function, to find a, b, and c, a is going to be the number next to your x squared. In this case, there's no number there, so I'm going to draw in a 1. That is a. B is the number next to the x term, so b in this case is 2, and then again a is the 1. And then c is the number all alone, so c in this case is negative 1. So negative 1 is c. Now, negative b over 2a, we're going to take that 2, make it negative, so negative 2 over 2 times our a value, which is 1. And that's what x is going to equal. So we plug that in, we see we have a negative 2 over 2, which is negative 1. So x is equal to negative 1, which means that if I were to fold my graph in half, it would fold in half somewhere along this line. And you don't have to draw that dashed line, but I know vertex is going to fall somewhere on that line. To get my y value, I have to plug negative 1 back into this function. So if I think of negative 1 squared plus 2 times a negative 1 minus 1, I'm going to have 1, negative 1 squared is positive 1, minus 2 minus 1. So 1 minus 2 minus 1 is negative 2, which means that my vertex is back 1, down 2. So right down here is my vertex. Now, there's a few different ways to go ahead and draw a parabola. You can either make a t-chart, if you think of an xy chart where you plug in different values of x and y, or different values of x, plug it into the equation, and then solve for what y will be. That is one technique that will always work for you. I tend not to like it because it's a lot more work. The lazy way of drawing a parabola is to know that you can count by squares. So if you go over 1, you go up 1 squared. So 1. If you go over 2, you go up 2 squared. So 4. 1, 2, 3, 4. Back 1, up 1, back 2, up 2 squared. 1, 2, 3, 4. And now you've drawn yourself a parabola. You could go over 3, up 9, and so forth, and that pattern will continue forever. One thing to notice is that pattern will only hold true when you have a 1 out front of that x squared. If you have no number out there, if you look at number 2, kind of sneak preview, we see we don't have that. We'll take a look at what we do in that case. You have to modify this rule a little bit. So it's not over 1, up 1 squared anymore. So let's go ahead and try number 2. We're going to make a graph of this. We're going to start out with that vertex, that negative b over 2a. And here we see that our b is going to be negative 12, and our a is going to be negative 2, the number out front of x squared. So negative 12, negative b, over 2 times a, and a is negative 2. I see that on top I have a positive 12, on bottom I have a negative 4, leaving me with x is equal to negative 3. And I should always write my x, so I remember it's x equal to negative 3. And so if I'm drawing where this is lining up with. I have that there. Now, what I need to do is I need to plug that -3 back into my original equation so that I can figure out what my y value is. So -3 plugged in here, I have a -2 times -3 squared minus 12 times -3 minus 19. And -3 squared is +9. +9 times -2 is -18. Here I have 12 times 3, both are negative, so it's going to be a +36. And then I have minus a 19. And if I add those all up together, it comes out to be -1. So I'm going to have my go back 3, go down 1, and that's for my vertex. Now, by my last statement, I said you'd go over 1, up 1, over 1, up 1, over 2, up 2 squared, and you'd have something that looks like this. That rule doesn't apply when you have a different number besides 1 at the start of your parabola. In this case, we have a -2 out here. What it says is take that rule and multiply everything by -2. So starting at your vertex again, instead of going over 1, up 1, we go over 1, up 1 times -2. So over 1, down 2. Over 1, down 2. And then we're going to do that again. So normally we go over 2 and then down 4, but we're going to multiply that 4 by -2. So we're going to go over 2, down 8. Over 2, down 8. And you can see that our graph is going to be not only downward facing, but also much narrower. That -2 out front, the negative makes it go down, the 2 makes it a narrower graph. And you'll see that that rule applies for problems like number 3, it's going to be narrower, number 5 is going to be narrower. Both of those are positive numbers, so it's going to be going up. Number 4, it might look a little tricky at first, but when you get to number 4, don't get confused by the lack of a C term. Just think of it as being +0 at the end if it gets confusing. And otherwise it should be the same type of problem. Good luck!